Good afternoon, my name is Yulii Horichenko and I am a master's student of Software Tools Department of National University Zaporizhzhia Polytechnic. Today I'd like to present you the results of our work on topic Research and Software Implementation of Intelligent Method of Energy Consumption Control. Home automation technologies are becoming more and more popular today. People use them to provide more comfort, flexibility, security and resource saving. But at the same time, the existing home automation systems do not provide intellectual support to users from the point of view of organizing the efficient consumption of electricity generated by alternative sources of electricity like solar and wind power plants. So the topic is relevant, and the purpose of this work is the research and practical implementation of intelligent methods of energy consumption control to increase the efficiency of electrical appliances usage and save electricity in home automation system that uses alternative sources of electricity. As the conducted studies have shown, researchers suggest using various intelligent methods and algorithms to solve the objective of minimizing the peak load in the grid. As a result of the review, the existing objectives of organizing efficient energy consumption in home automation system and popular methods of solving them were divided into main groups. They are optimization of scheduling for home appliances and forecasting electricity consumption of generation. On the basis of this research of popular intelligent methods in the field of organization of optimal electricity consumption, it is proposed to develop a complex intelligent method of energy consumption control to save electricity in home automation system that uses alternative sources of electricity, based on two main objectives that I was talking before. A complex intelligent method of energy consumption control should be developed using artificial neural network and particle swarm optimization algorithm with some improvements. The UML activity diagram of the complex method shows the algorithm that involves two main stages: forecasting of electricity generation and creating an optimal hourly schedule for the usage of electrical appliances. Since it's impossible to create a universal neural network that will be suitable for various objectives of home automation system, several computer experiments have been conducted to select a neural network model that will provide the highest prediction accuracy. The implemented models based on the feed-forward neural network demonstrated good forecasting results. Among the studied models, the one with 4 parameters and using the Adam optimizer turned out to be the best. So it's advisable to use this model to implement a complex intellectual method for increasing the efficiency of using electrical appliances. The next stage of the implementation of the complex method is the creation of an optimal schedule for electrical appliances using the particle swarm optimization. The goal of optimization is to create a schedule that will use as much electricity as possible from alternative power sources and minimize the consumption of electricity from the external power grid. Since solar and wind power plants provide the generation of a limited amount of electricity, it was proposed to improve the particle swarm optimization by introducing a priority system. Priority system will allow the user to choose the most important household appliances for him, and in case of insufficient electricity generation, the algorithm will suggest not to use those with the lowest priority. The UML diagram demonstrates the interaction between the developed intelligent support subsystem and other automation system components. First, a user connects to an intelligent support subsystem and chooses household appliances that are stored in a database. After that, the developed intelligent support subsystem downloads weather forecast for the next day, creates an optimal schedule, and shows it back to the user. Based on the developed method and algorithm, an intelligent support subsystem was created, which integrates with the OpenHub home automation platform and includes 4 modules. The main module is a module of a schedule optimization that allows to create an optimal schedule for the home appliances. Module of indicators monitoring, which analyzes energy consumption data in real time and sends a message to the user in case of exceeding electricity consumption. Module of forecasting of electricity generation for the next day, using the weather forecast and historical energy consumption data stored in the database. The forecasting module is called when necessary, and the forecasting results are used during the generation of the optimal schedule. The subsystem is implemented as a web application using the Java programming language and the Spring framework. The electricity generation forecasting module is developed in the Python programming language using the Keras library. All necessary data is stored in the Mongo database, which is suitable for storing large volumes of information. The input data for the forecasting module is the weather forecast for the next day, which is downloaded using Weather API. The developed intelligent support subsystem was integrated with the OpenHub platform, and now it's at the stage of experimental operation in real home automation system. The main component of the investigated real home automation system is the OpenHub platform. The developed intelligent support subsystem interacts with the local database included in home automation system and receives all the necessary indicators from the electricity measurement modules, analyzes them in real time, and also uses them for neural network training. The user can connect to the intelligent support subsystem using a browser. He can create an optimal schedule for using appliances, monitor energy consumption and generation in real time, and receive all important messages from the subsystem. And finally, I'd like to draw some conclusions of our work. As a result of the conducted research, a complex intelligent method of controlling energy consumption in home automation system was developed based on forecasting electricity generation with the maximum use of alternative sources, as well as optimizing the schedule of use of electrical appliances to minimize electricity consumption from the external power grid. The scientific novelty of the work consists in the development of an intelligent method of energy consumption control, which differs from the existing ones by a comprehensive approach based on forecasting electricity generation using a feed-forward neural network, as well as optimizing the schedule of electrical appliances usage based on the particle swarm optimization with the proposed system of priorities. The practical significance of the work is that the integration of the developed intelligent support subsystem in home automation system will allow controlling the processes of the electricity generation and consumption, increasing the efficiency of using household appliances and saving resources. And that's all for now. Thank you for your attention.